Hello everyone, welcome back to our channel. If you are new here, I am Dr. Lee. Today, we're focusing on the SMO Junior. For those of you who are preparing for your first SMO Junior, here is what you need to know. The paper consists of 25 questions. Usually the first 5 questions are multiple choice question MCQ, then followed by short answer problems with integer solution. Let me repeat, integer solution for the short answer problems. So this means that if you do not get the integer solution, something wrong. Next, you have 2.5 hours to navigate through these questions, each worth the same 1 mark, whether they are straightforward or complex. To optimize your scores, it's crucial to manage your time wisely and make strategy choice about which question to tackle. In this video, we are focusing on the SMO Junior 2023. We are not going to cover all 25 questions, and I encourage you to focus on some questions if you are new to this SMO. In this video, we'll zoom in on 10 to 15 of them. Why? Because focusing on this question to a decent result, aiming for a bronze medal. And that's fantastic achievement for any beginners. I'll walk you through 10 to 15 selected questions, and I'll share some tips to boost your confidence and efficiency during the competition. Let's get started. You may not start with question 1 of the paper. Instead, start with the question that you are very confident in. Personally, I prefer to start with questions that are less wordy and more straightforward. So let's start with question 2. How many non-congruent triangles with integer side length have parameter 7? The options are A1, B2, C3, D4, and E5. Try to solve it before moving on to the solution. Let's consider the side length as A, B, and C, where A is less than or equal to B is less than or equal to C. Given that A plus B plus C equals 7, and to form a triangle, C must less than A plus B, which is an aspect of the triangle inequality. From A plus B plus C equals 7 and C being less than A plus B, we derive 2C less than 7, so C is at most 3. If C is 3, then A plus B equals 4. The pair A and B can be either 1, 3 or 2, 2, leading to 2 triangles with side length 1, 3, 3 and 2, 2, 3. If C were less than or equal to 2, since C is a bigger side, A plus B plus C would sum to at most 6, which contradicts our parameter requirement. Thus, no valid triangle exists with C less than or equal to 2. Therefore, there are exactly 2 non-congruent triangles possible with a parameter of 7, making the correct answer B. If you got this right, well done. You're one step closer to achieving that medal. Next, let's look at question 3. The median and mean of 5 distinct numbers 4, 7, 10, 11, and n are equal. Find the sum of all possible values of n. The options are A, 18, B, 21, C, 26, D, 29, and E, 35. Try to solve it before moving on to the solution. First of all, we know that the mean is 4 plus 7 plus 10 plus 11 plus n divided by n, which is 1 over 5 times 32 plus n. It is important to note that n may not be the largest number among these 5 numbers. We may split it into few cases. If n is greater than or equal to 10, then the median is 10, and so 10 equals 1 over 5 times 32 plus n, which implies that n equals 18. If n is less than or equal to 7, then the mean is 7. And so 7 equals to 1 over 5 times 32 plus n, which implies that n equals to 3. And finally, the case that many students miss out, n is in between 7 and 10. This means that the median is n. And so n equals 1 over 5 times 32 plus 5, and hence n equals to 8. Get the sum of 3, 18, and 8. We have 29, and the answer is D. If you miss the case where n is the median itself, you might have calculated B, 21, which is incorrect. This question is tricky as it appears straightforward but can easily lead to errors. Always consider all possible scenarios in problems like this to avoid missing key details. Next, I'll skip this geometry in question 4 and I'll certainly come to it later. Now look at question 6, which is about factorization. Question 6. The product of the age of 3 adults is 26390. Find the sum of their ages. A person is an adult if he or she is at least 21 years old. So it's clear that we need to get the factorization of the number 26390. Noticing that 2690 is 2639 times 10. We can break it down further. 2639 is 7 times 377. Continue our factorization. 377 can be split into 13 times 29. Therefore, 26390 break down to 2 times 5 times 7 times 13 times 29. To solve the question, we need to write 26390 as a product of integer, each at least 21. By pairing smaller factors to reach this whole, we combine 2 and 13 to get 26, 5 and 6 to get 35, and leaving 29 by itself. Therefore, the sum of their ages is 26 plus 35 plus 29, which totals 90. Next, I'll skip question 8 and 10 for now and see if there are any easiest one. This brings us to question 9. Question 9. The product of 2-digit number x4 and the 3-digit number 3yz is 7657. Find the value of x plus y plus z. At first glance, we can determine that x cannot be more than 2. Otherwise, the product of x4 and 3yz would exist 7657. Let's take x equals 2. Now dividing 7656 by 24. Give us 319. Therefore, the value of x, y, z are 219. And consequently, x plus y plus z equals 2 plus 1 plus 9, which is 12. Next, question 10 needs the formula a plus b squared equals a squared plus b squared plus 2ab. Using this formula, x squared plus y squared equals the square of x plus y minus 2xy, which is 12 squared minus 2 times 10, which equals 144 minus 20, and hence it is 124. Next, x4 plus y4 equals square of x squared plus y squared minus 2x squared y squared, which is 124 squared minus 2 times 10 squared. We need to calculate the value of 124 squared carefully. And we'll get 15376. So the answer is 15176. So far we have covered 5 questions, with another more to go, and I'll make it into the next video. That concludes today's lesson. I hope you found this video insightful and are excited for more medical challenges. Until next time, take care and bye bye.